Hi. In the previous video, we saw how to calculate vector components. In this video, we'll do the opposite. We're going to start with the vector components and then learn how to calculate the magnitude and the angle of the vector. So our vector r in this case is given, and we see that the components, they're written in what we call the unit vector form, but this just means simply that rx equals minus 2 meters, while ry equals minus 5 meters. Now again, first thing you want to do is plot your vector in a coordinate system. And so we've got a coordinate system here, and it turns out that the vector components, minus 2 meters, minus 5 meters, what they do is they specify the point in the xy plane where the tip of the vector arrow ends at. So I just got to go to the x-axis and I see minus 2, okay. And then I see for the y-axis minus 5. Where is that point? It's right there, right? So now I draw my vector. I always start from the origin. I draw straight out to the point where the vector components specify it in the plane. And so this here now is my vector r. So we've drawn a picture of it. It's always the first step that you want. And from here, we're going to use trigonometry to go ahead and calculate what the magnitude and angle of the vector are. So I'm going to draw a bigger picture of this so I can see it a little better. I know that this is a picture like this, right? So here's a right angle here. And here's a hypotenuse here, right? Of course, this is my vector here. And this is my rx equals minus 2 meters. This is my ry equals minus 5 meters. And my hypotenuse here, r, I don't know what it is. And I'd like to calculate the angle, the direction of this vector, right? We want to specify it as an angle measured counterclockwise from the plus x-axis. I can really choose either this angle or this angle. I'm going to pick the first one. So let's call this temporarily just angle theta for now. So we've got our triangle, and the goal is to figure out what is theta and what is the hypotenuse, the magnitude r. To do this, we're going to go ahead and figure out. We're going to use two things. One is the Pythagorean theorem, right? So if I look at this triangle, I know that for the Pythagorean theorem, the hypotenuse squared is equal to the sum of the sides squared. So that's one thing. And the other thing I'm going to use is the tangent function. Remember, tangent is equal to opposite over adjacent. And in this particular picture here, we've got the adjacent side next to angle theta, and we've got the side opposite of angle theta, right? Now, I actually want to get the angle theta, not tangent theta, so I need to use the inverse function. To get the angle, I've got to go tangent inverse, the inverse function of the ratio of the opposite over the adjacent sides. Now notice something here that when I do my trig, I'm going to ignore the minus signs. I've already drawn this vector, and I know that this is a third quadrant vector, right? Here's the first quadrant, right? X is plus, y is plus. Second quadrant, x is negative, y is plus. Third quadrant, x is negative, y is negative. Of course, this is a third quadrant vector, right? And the fourth, x is positive, y is negative, right? But when I calculate the angle, I'm going to ignore the negative sign here. I'm just going to call this side 2 and this side 5. In fact, I don't even need to worry about the units even, because when we do the ratio, we'll see they cancel out. So let me get the angle first, all right? Using the inverse function, theta is equal to tangent inverse opposite over adjacent. For this angle, the opposite is ry, right? So this is going to be ry over adjacent Rx. And as I said, I'm going to ignore the signs on these completely. I can just put absolute values over this. If I go ahead and plug this stuff in, I'll have tangent Ry 5 meters divided by Rx 2 meters, and I cancel the meters out. They're gone. It's a ratio. That's nice. And if I put this into my calculator, I'm just going to get an acute angle between 0 and 90. And so I end up calculating this. All right, so we're not done yet if we want to specify this counterclockwise from the positive x-axis, right? We've just figured out here that this angle is 68.2 degrees. But if I'm going to start from 0, positive x, right? I got to go counterclockwise through these other angles, right? So I'm going to go like this. 0, 90, 180 plus 68.2, and that is going to give me an actual direction angle here of 180 plus 68.2 degrees, and this tells us it's 248.2 degrees. So that is counterclockwise from plus x. Okay, so that's the direction. Now, if I want to do the magnitude, what's the hypotenuse here? That isn't always a pretty easy one to do. We're going to use the Pythagorean theorem here. And so I'm going to write this as r squared, rx squared plus ry squared. Let's take the square roots of both sides. Typically, math says this is plus or minus, but we know that magnitudes are always positive, so we just take the positive sign there. And so r is equal to the square root of rx squared plus ry squared. And in this case, if you want to use the minus signs or not, it doesn't matter because you're going to square it, right? If I put in minus 2 meters here for Rx, I'm going to square it. It's going to be 4 meters squared, right? Over here, same thing. Ry minus 5 meters, square it. And so we're going to get some numbers here, right? We're going to get 4 meters squared plus 25 meters squared. We're going to get the square root of 29 meters squared. And of course, when we put that into our calculator, we come up with a number equal to 5.39 meters. And notice again that the meters squared, right? Got to do the same math to that. The root is going to cancel the square. It ends up in meters. It's good like we want it to be. So we've just figured the magnitude, and here it is, and we figured out the direction, counterclockwise from the plus x. Let's just practice real quick. What if we want to do the direction with respect to the cardinal direction? So here's north. Let me get a different color here. Let's see. Here's north up, south down, west to the left, east to the right. What is the well, how do we specify this same direction in cardinal directions? So we could start from the west here and then move towards the south by 68.2 degrees. Remember, we do this backwards. Start west, move towards the south by 68.2 degrees. So that's another way to specify the direction. And of course, if we want to get the alternate way, right, start south and move to the west, well, that's the complementary angle, 90 minus 68.2. That's going to be equal to 21.8 degrees. And here we're starting from the south and we're moving towards the west by 28 degrees. And so we've got 3 different ways to specify the direction of this vector. All 3 of these ways are equally valid.